So in this problem, I've titled it More Than One Restriction to Consider. So it's a square root, right? The function is a square root. But we also have to remember that we can't divide by 0, so we have another restriction when we look at that part. They're not asking us to find the inverse. They just want us to find the domain of the function. Okay, so two things. Don't forget, x cannot be 1. And then we're going to say we have to have x plus 2 times x minus 3 over x minus 1. It has to be greater than or equal to 0. Okay? So it needs to be greater than or equal to 0. Okay, that's how I said it. I'm going to scroll this up. And we have to have it be positive because you've got to take the square root of a positive number, right? You might remember doing these in the past. I'm going to draw a number line. So it's an inequality that has a rational expression. And there's a way that we solve these. So this is how I do them. So I look at the points where it's 0. So like -2 and 3 and 1. All right, so both in the numerator and the denominator, they had it factored for us. So we're looking at when do those factors equal 0, because that's going to change things. So then I graph those on my number line. Here I am at 0, here I am at -2, here I am at 1, and here I am at 3. Okay, so I am considering, like if I'm just looking at this part right here, then I would say, okay, what can I have? Can I have it be -2? Can I have it equal 0? Because see, that would make the numerator 0, the whole thing would be 0. Can I have it be 1? No, I can't really have it be 1 because that makes the denominator 0. That's that second restriction I was kind of talking about, okay? So I cannot have this actually equal 1 because then I'd be dividing by 0 and I can't have it. Can I have it equal 3? Yep. It can be 3. It can be 0 in the numerator. It just can't be 0 in the denominator. Now, I put solid lines for the numbers I'll be including in the domain and a dotted line for the one that I'm not including in the domain. And then what I do is I use test points. So I take my function, well, my expression, I guess, x plus 2 times x minus 3 over x minus 1. And then I'm saying, when is that going to be greater than or equal to 0? And I pick a point in each of the 4 sections. So you can see I've got a section here, whoops, a section here, a section here, a section here, and a section here. And so by picking a point in each section, I can determine if it's true or if it's false, and then I'll know whether to include that section. I only need 1 point in each section. So I usually tell students, okay, think of a number less than -2. They almost always say -3, but you can be more creative. So I'm going to be plugging in -3. This would be called a test point. It's testing that part of the graph. All right, if I put in -3, I would get in the numerator -1, and I would get a -6, and then in the bottom I'd have a -4. Now, does that turn out to be a positive number or a negative number? Well, you have 3 negative signs, so it'd be like -3 halves, and is that greater than or equal to 0? No. So don't include that section, not that section. All right, I don't usually write out all that math, so I'm going to scroll up a little more, and I'll show you how I usually think about it. So I need a point in between -2 and 1. Now let's say I use 0. 0 is between -2 and 1. All right, so what happens if I put a 0 in the first parenthesis? I get a positive number. What happens if I put 0 in the second parenthesis? I get a negative number. And what happens in the denominator? I also get a negative. Okay, now I have a negative divided by a negative. Is that going to be negative or positive? It's going to be positive. Are positive numbers greater than or equal to 0? Yes. So yes, I'm including this section. Okay? So I think of it in terms of positive and negatives. I don't actually think of the actual numbers, but you can do it either way, whichever way makes more sense for you. Now I need a test point between 1 and 3. All right, I'll pick 2. So if I put in a 2, I'll do the numbers this time. So 4 times negative 1 over 1. If I put in 2 for all the x's. All right, that turns out to be a negative 4. And is that greater than or equal to 0? No. So not that section. And then I need a number bigger than 3. So I'll use 4. So I'll do 2 with the numbers that I write out and 2 that I didn't. Okay, so I'm thinking about these parentheses. If I put a 4 in there, it's going to be positive. If I put a 4 in here, it's going to be positive. And if I put a 4 in here, it's also going to be positive. So if I have a positive times a positive divided by a positive, that's positive. And are positive numbers greater than 0? Yes. Now, before I write the answer, you'll notice that the sections alternate. One didn't work, the next one did. One didn't work, the next one did. That does not always happen. Students like to think that that always happens, but it doesn't always. So that's why we do the test points. Sometimes it works out that way, and it doesn't necessarily mean that the first section isn't going to work and the next one will, or the other way around. But that's why we do the test points. Okay, so just a plug for test points there. So what is my answer going to be? Well, I need the points between negative 2 and 1, and I'm including the negative 2. So negative 2 to 1, but I'm not including the 1. So that takes care of that section right there. Now my little part here looked confusing. Okay, we'll take that out. I don't want the next section, but then I want this section over here. So I'm going to union it. It's going to be a bracket 3, because I want to include the 3, to infinity. And then that would be the domain. Okay,